Lake Michigan still looks alive. The surface moves. The shore stays recognizable. Boats still cross the water. But the waterline is already retreating, and 40 million people depend on this system for water they assume will always be there. That one visible sign already tells you the system is changing underneath. The retreat is not seasonal variation. It is not a temporary dry spell. It is a structural shift in how much water the Great Lakes hold. And through a forensic lens, that shift describes exactly how a freshwater reserve that contains nearly 20% of the world's surface freshwater can fail while still looking normal from shore. The lakes are losing more water than they gain. The bathtub is draining, and the loss is spread from there. By the end of this case file, you will understand exactly how that cutoff happens and why the surface gives you no warning before it does. We view Lake Michigan as stable. We see 5 massive lakes, endless water, a resource so large it feels permanent. But through a forensic lens, Lake Michigan is not a stable reserve. It is a system running a water deficit, and the visible retreat of the shoreline is the first symptom of a much larger imbalance. Look at the waterline itself. In 2013, Lake Michigan and Lake Huron, which are technically one connected body of water linked through the Straits of Mackinac, hit the lowest water level ever recorded in history. The drop was sudden. The plunge was unprecedented. Piers that had stood in deep water for decades were suddenly stranded, hundreds of feet from the new shore. Boat launches became useless. Harbors went dry. Multi-million-dollar docks sat on exposed lakebed. That visible retreat is not just a surface change. It is the physical proof that the Great Lakes are now consistently losing more water than they receive from rain and snow. Scientists call this measurement net basin supply. It tracks how much water enters the system versus how much leaves through evaporation and outflow. And across all 5 Great Lakes, net basin supply is declining. The system is in deficit. The bathtub is not refilling as fast as it drains. That is not a drought. That is a permanent shift in the water balance of the entire region. And the deeper part is this. Only about 1% of the Great Lakes' total volume is renewed each year by precipitation. The system does not bounce back quickly. When water leaves, it stays gone. The lakes lose water through 2 main pathways. The first is outflow. Water flows out through the St. Lawrence River to the Atlantic Ocean. That pathway is relatively stable. The second pathway is evaporation, and that is where the collapse accelerates. Warmer air temperatures and warmer lake surface temperatures turn the lake into a giant humidifier. Trillions of gallons of water evaporate directly into the atmosphere. The lakes are literally vanishing into thin air. And the mechanism gets worse. Ice cover used to act as a protective lid during winter. When the surface froze, evaporation slowed. Cold air could not pull moisture from a frozen surface. But ice cover is declining across all 5 lakes. Lake Superior, the headwater of the entire system, is now one of the fastest warming large lakes on the planet. Without ice, the lakes stay exposed all winter. Cold, dry winter air hits warm, open water and accelerates evaporation, even during the coldest months of the year. The same cold air that used to protect the system now drains it. And the water that evaporates does not stay local. It gets carried inland and dumped as massive lake-effect snow bands. The snow falls far from the lakes. It does not return to the basin. The system effectively drains its own volume and deposits it hundreds of miles away. Winter vapor plumes become a one-way transfer. The water leaves and does not come back. Now look at what that water loss does to the infrastructure built on top of it. The Great Lakes region supports a $6 trillion economy. If it were its own country, it would rank as the third largest economy in the world. That economy depends on stable water levels. Ports were built for 20th century averages. Power plants were designed for specific intake depths. Municipal drinking water systems were engineered assuming the water line would stay predictable. None of that infrastructure was built for a system in deficit. And the mismatches are already visible. Cargo shipping is the clearest example. For every single inch the water level drops, large cargo ships must shed up to 270 tons of weight to avoid hitting the bottom of shallow channels. The ships cannot carry full loads. They run light. That means more trips to move the same amount of cargo. Ore boats supplying the massive steel mills near Chicago and Gary, Indiana, are forced to make multiple extra runs. Shipping costs rise. Supply chains strain. The entire industrial base of the region becomes less efficient because the water is too shallow to support the system it was built for. And the problem cascades. Lower water levels reduce the flow to the Niagara and St. Lawrence rivers. Those rivers feed hydropower plants that supply electricity to millions of people. Less water means less power generation. The energy grid weakens. Coastal wetlands that act as natural filters and fish nurseries dry up as the water line retreats. The wetlands disappear. The ecosystem loses its buffering capacity. Shoreline instability increases. Beaches erode. Bluffs collapse. Entire sections of coast become unstable because the water that used to support them is gone. The same retreat that looks like a scenic low-water year is actually the visible sign of infrastructure failure, spreading across an entire regional system. But the most direct human consequence is drinking water. Over 40 million people in the United States and Canada depend on the Great Lakes for their daily drinking water. Municipal intake pipes are built to draw water from specific depths. As the water level drops, those pipes can become exposed. They can start drawing warmer, lower quality water from near the surface instead of cooler, cleaner water from depth. Some cities are already forced to extend their intake pipes farther out into the lake or deeper down to reach usable water. That costs millions of dollars. Smaller communities cannot afford the upgrades. And if the water level drops far enough, the intake pipes stop working entirely. The taps go dry. The system that supplies drinking water to one of the most densely populated regions in North America becomes physically incapable of delivering water to the people who depend on it. That is not a hypothetical. That is the exact failure mode already visible in the infrastructure mismatch happening right now. Chicago's entire waterfront was engineered for specific water levels. The city reversed the flow of the Chicago River more than a century ago to prevent sewage from contaminating Lake Michigan. That reversal only works if the lake stays higher than the river. Extreme low levels could theoretically cause the river to flow back into the lake, contaminating the fresh intake with sewage. The same engineering that protected the city's water supply becomes the pathway for contamination when the water balance shifts. and there is no easy fix. The sheer volume of water in the Great Lakes is so massive that large-scale engineering solutions to artificially raise levels are practically impossible. You cannot pump enough water. You cannot divert enough flow. The system is too big to engineer your way out of a structural deficit. The only solution is to stop the deficit itself. But the deficit is driven by warming temperatures and declining precipitation. Those are climate-driven changes. They are not reversing. Scientists describe what is happening not as a temporary drought, but as a permanent long-term shift to a new, drier climate baseline for the Midwest. The Great Lakes are not experiencing a bad year. They are entering a new normal. And the new normal is a system that holds less water, supports less cargo, generates less power, and supplies drinking water to fewer people. Now look at what is being exposed. Receding waters reveal industrial sediments contaminated with legacy toxins, like polychlorinated biphenyls. Those toxins were buried underwater for decades. As the water retreats, wind and waves stir them up. The contamination re-enters the water column. The same drop that looks like a natural fluctuation is also uncovering a toxic past that was supposed to stay buried. The water quality degrades. The drinking water risk increases. The system loses usable water, not just because there is less of it, but because what remains is harder to treat and less safe to drink. And the surrounding water table sinks with the lake. As lake levels drop, the aquifer that feeds inland wells drops too. Wells that used to reach water now run dry. Communities miles from the actual shore lose access to groundwater because the entire regional water table is linked to the lake. The collapse is not contained to the shoreline. It spreads inland. It affects people who never see the lake but depend on the hydrological system it anchors. You, the viewer, should watch the waterline itself, not the storms, not the seasonal high watermarks. Watch the long-term average. Watch whether the lake refills after a dry summer. Watch whether winter ice cover returns. Watch whether the cargo ships run light or full. Watch whether your city announces, take pipe extensions. This, water treatment upgrades. Those are the signs that the deficit is continuing. Those are the signs that the system is not recovering. The surface can look calm and still appear healthy, while the underlying water balance continues to degrade. The Great Lakes still look like an endless resource. That is what makes the collapse harder to read. So here is the answer to the question from the beginning. This is how 40 million people get cut off. The lakes lose more water than they gain. The waterline retreats. The intake pipes that supply drinking water to entire cities become exposed or draw contaminated water. And the infrastructure built for stable 20th century levels physically fails to deliver water to the taps. That is not a projection. That is the system working exactly as it is currently built. Lake Michigan is not dead yet, but that is the point. The crisis is not in a lake that looks empty. The crisis is in a water body that still looks normal from shore and no longer functions normally inside. The 40 million people who depend on this water do not see the mechanism. They see the surface. Now you do.